Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is FigureOutable challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you have found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians do. Not only are algorithms not particularly helpful in teaching mathematics, nor fun, but rotely repeating steps actually keep students from being the mathematicians they can be.
Absolutely. So last week we started talking about kind of a big topic, right? Building thinking classrooms.
Mm-hmm.
And you shared what you think about Peter Liljedahl's work and how we had done some of the things. And you get asked about his work all the time and how your work fits together. So today we're going to talk a little bit more about maybe how you are a little different. Is that a fair way to say that?
I think so.
Little bit.
In just a very professionally respectful way.
Yep.
I'll just make some suggestions about, I think, the best ways to maybe implement Dr. Liljedahl's work. By the way, Kim, I'm going to just compliment you on saying his name. Do you have any people I work? I'll like be talking to people and they're like, you know that Liljedahl? I'm like, hey, guys, it's not that hard.
Yeah.
Liljedahl. Now, Dr. Liljedahl, you can tell me I'm saying it wrong, and I will then happily apologize because I hope I'm not. All right, so let's dive into maybe some nuances of kind of my perspective on the best ways to use his first 3 teaching practices. I do want to talk more about his other 4 chunks, or he has 4 chunks of things. I want to talk about the other 3 at some point, but I'm gonna hang with that first set of teaching practices in this episode. So something really important to, if you have not listened to the last episode, you're going to need to listen to this before this one, because I'm not going to re-explain stuff. So something really big to consider. I think that people that are on the BTC, Building Thinking Classrooms, sort of bandwagon, are telling you to do vertical non-permanent surfaces in visibly randomly chosen groups all the time. We are saying some of the time.
Yep.
So let's dig into that a little bit. Do I like the idea of putting my students in my university classes, participants at workshops, students in classrooms up at vertical, erasable surfaces, giving them thinking tasks, and asking them, separating them, splitting them, putting them in visibly randomly chosen groups? Yes, when it's appropriate. And so I would say that's very appropriate when we give them the thinking tasks that he just suggested. That's part of one of his first pillar of things, is that it's got to be thinking tasks. However, he suggests that it's with non-curricular tasks, that you do that at the beginning of the year, because if you do it with regular math tasks, kids will they'll do what they've always done, and they'll try to mimic, and they won't dive in and think. But if you give them non-curricular, sort of not the kind of questions they're used to looking at, if you give them those non-curricular tasks, they'll look around, they're like, wow, this is really different. You know, like, we're standing up, we're at these whiteboards, we only have one marker, he or she clearly put us in this randomly chosen group, and this is kind of an interesting problem. It doesn't look like the math problems that we're used to solving. maybe we could reason through this. And kids will dive in and they'll think and they'll help each other. And it's kind of their interesting problems. And they don't look, it doesn't look, because you're at vertical non-permanent surfaces, or feel, you're in these randomly chosen groups, like the math that they've done before, because you're doing different, the math looks different. And so because of all that together, kids are kind of willing to dive in and do some thinking. Then you kind of do this switchy thing where once kids are thinking, then he says, now just give them math tests, just give them normal math tests. And because they're like, this is what we do here, they'll continue to think about those math tasks. I think he probably has a point. I think it probably works just fine to do that. I don't think you have to do that. In other words, what's my that? I don't think you have to start the year with non-curricular tasks. If you start the year with really good, rich curricular tasks. So when you give them that really good, rich curricular task, put them up at the vertical non-permanent surfaces, randomly choose their groups, give them the one marker and say, go. But give them a curricular task that's interesting. It doesn't look like the ones that they were rote memorizing their way through the year before, but it could actually be the curriculum that you teach. Now, that's not easy to come up with what those tasks are. It's one of the things that I work on, and other really good people I know, Kyle Pierce and John Orr, are working on that. We've got a colleague in Norway. I totally just swallowed the throat lozenge I had in my mouth. Sorry.
I'm sorry.
Good heavens. James, I know your name. I don't know. Do I know how to pronounce his last name though? James.
Oh, we already butchered that once.
Micklebust, Hampshire. You're gonna. He'll tell me if I totally. So he's really super interested in at least collecting really good rich tasks. Kathy Fosno has amazing rich tasks. I think anyway. There's some places that you can get rich tasks. I don't think it's trivial to come up with curricular rich tasks, but I do think it's possible. I've definitely written some, especially in our in all of our building powerful mathematics workshops. We've got rich tasks we would suggest. So that's a thing. You clearly heard me last episode and this episode say we do put our students and the teachers we work with up at vertical non-permanent surfaces in these randomly chosen groups, and we do these curricular rich tasks and get students thinking. One thing that I would slightly differ on is if you can find and create or share with each other really good, or get from me or other good people, really good rich tasks, then you don't have to start with non-curricular rich tasks. So that'd be a place where I would slightly differ. And you know what, Dr. Liljedahl, maybe you would agree with me. You're like, well, yeah, if you can find a really good one, go for it. They're just hard to find. So maybe we agree on that. Another thing, though, that I think maybe I'm actually kind of sure we might disagree a little bit on is that's the only time that I would put students up at those vertical non-permanent surfaces in those randomly chosen groups. There are other things I would do in classroom teaching, and one of those huge things I call problem strings. So if you've listened to the podcast for longer than about 15 seconds, you've heard me do problem strings lots. I love problem strings. I think they're a super effective way to help cinch things, to help introduce things, to help refine things, ideas, concepts, strategies. Really good way of teaching. And I think I'm just gonna state, I believe problem strings are best done whole group with students at their desks. It doesn't have to, I was gonna say, with something to write on with, but it doesn't have to be non-permanent. It doesn't have to be their notebook. It could be either of those. But problem string success hinges on the discussion between each problem and the modeling of the teacher between each problem. One of the things he suggests is that you defront your classroom, meaning there's not this teacher at the board and the sage on the stage, and all the thinking happens with the teacher and the kids are just mimicking. And so that's one reason why you put them around the room at these vertical non-permanent surfaces. And I'm totally cool with that when kids are doing those rich tasks at the vertical non-permanent surfaces in those visibly randomly chosen groups. But when we're doing a problem string, I think the teacher is at a board and the students are at their desks. And I don't know that it has to be the front of the room. I think it could be any one of those now vertical non-permanent surfaces you have around the room. So when you do a problem string today, you could do it at this whiteboard. And when you do a problem string tomorrow, it could be at that whiteboard. And when you do a problem string the next day, it could be over there at that. And when students come in, you could just say, hey, today, orient your desks. I'm going to be here. Today, it doesn't matter where the desks are because you're at vertical non-permanent surfaces doing a rich task. But today, right now, orient your desks because I'm going to be right here and we're going to do a problem string. Hey, for this problem string, Everybody oriented? Yep, the desks are there. Cool. Everybody ready? Here's the first problem. Do the first problem. All right, now I'm going to choose someone to share their thinking for that first problem based on what I've seen as I circulate, based on questions I ask. I'm going to represent that thinking in such a way because I know where the problem string is going. And so I'm going to orchestrate a final display by starting with that very first problem and representing it with a purposely chosen model. I might have a kid say, well, I did it on an array. And I might go, okay, tell us what you did though with the numbers. Where'd you chunk them? And then I might still put those values in a ratio table. Like, because I know where I'm going with the string, know your content, know your kids. I know the content. I know the goal of the lesson. And so because I know that, I'm going to say, yeah, but how'd you use those chunks? Ooh, I'm going to put those chunks up in these equations. I'm going to choose the model because I know where I'm going. Then I'm going to say, does everybody understand Kim's strategy for that one? Can somebody restate that strategy? Does that make sense? Okay, everybody's good on that one. All right, cool. Next problem. Everybody solves it. All right. Now everybody solves it however they want. And I'm going to encourage them to think and reason however they want. And I'm going to say, okay, cool. Based on where I know I'm going, I don't say that out loud, but based on where I know I'm going, I look around or I ask certain questions. I choose someone to share. I represent that thinking in such a way. Now, depending on the string, I might choose 2 students to share. We might compare the strategies. It depends on the problem string, but I'm representing the thinking and I'm orchestrating a conversation. Okay, y'all, but so-and-so in the first problem did this. Why did so-and-so in the second problem did that? Do those have anything in common? Oh, did the numbers influence how they chose that? That's interesting. Well, based on that, I wonder how you might think about this problem. And now I get the third problem. Again, they can solve it any way they want, but I have been nudging certain relationships by what we're celebrating during the conversation and the modeling, the representing of the thinking, the making the thinking visible. I'm subtly nudging kids to consider relationships they might not be considering while they're solving the problems. Next problem, same. We keep going. And by the end of it, we're having a conversation about a certain set of relationships that are leading towards a certain strategy, model, or big idea. And I'm not going to pretend that we've cinched it, that everybody by the end of the string is doing it, but everybody by the end of the thing is considering it. They're thinking about it. And we've started to create those mental connections. If you do that problem string in groups at those vertical non-permanent services, chances are super high that students will solve those problems the way they are inclined to solve them the whole time, because there's not that conversation and that nudging and that making thinking visible happening in between to give them other ideas, to help them think about other things. Does that make sense, Kim?
Yeah, absolutely. I mean, I think so much of it in a problem string is about reflection and nudging and conversation, that you're the guide, right? Like, you are crafting the conversation based on an end goal, and you drop things along the way to make it become something within the kids' zone of proximal development. Like they're aware of the thing because of the hints that you've laid or that other students have laid along the way.
And it's interesting when you say drop things, I think you mean drop in, like things that you lob out, things that you purposely, hints you give, but you also drop things, meaning that kids might be doing something that's fine, but it's not it's not helping where we're headed. And so you de-emphasize it. You literally drop it. Like a student might say, hey, but I want to share my strategy. And you might be like, I believe you, not now. And then you move on.
Yes.
Like we very politely say, during your problem string, I choose who shares because I'm moving the math forward. We're always with an eye towards making sure that all students are being supported and presented and promoted as sense makers. Like, we're always with an eye towards making sure that we're giving students what they need to be successful. So we're not choosing in fact, it's funny, Kim, we're not choosing necessarily the right kid or the brightest kid or the quickest kid, right? We're often choosing the kid who will maybe make the conversation a little muddy, so that in the cleaning up of the conversation, in the refining of it, in the clarifying, everybody learns more. If we call on the kid with the most clear explanation, then why if that's what teaching is, let me get the most clear explanation out and we're done. Then why didn't I just say it? Why go through the whole? Because we would suggest that's not learning. That's not what gets us the most bang for our buck.
Yeah.
So we are suggesting that putting kids up in visibly randomly chosen groups at vertical non-permanent surfaces with rich curricular tasks is a fantastic thing to do when you are doing those rich tasks. In my kind of curriculum, that happens 2, maybe 3 times a week, where we're doing those rich things, and then we're going to follow it with a congress. I think, I'm going to talk about that later. We follow that with what we call a math congress after Kathy Fosno, where we have a conversation about that rich task. That's happening maybe 2 or 3 times a week.
Yeah.
More often than that, we are doing problem strings, which are kids in a whole group at their desks where the teacher is focused on, I've got an outcome here to move the math forward. I'm nudging, I'm celebrating certain things so that certain patterns today are the ones that we are fussing with. It's not like I'm slapping kids' hands and saying, no, not that. No, stop that. Not at all. I'm just, like we said, letting some things drop, and I'm dropping in things so that certain patterns, relationships, and connections are the ones that are paramount for that day, and that we're creating more and more sophisticated thinking for that particular day.
Yeah. And the exciting thing for the listeners is that it's not an either or. You can have both. You can do both, and you should do both. It's not, which path do I have to pick?
Absolutely.
They just have their own importance for their own moments at different times.
Absolutely. So definitely not saying, chuck that Building Thinking Classrooms book. No, absolutely. I think there's some wonderful things in there.
So valuable.
Especially very valuable. And we'll talk about more of them in his other 3 chunks of things. I think there's definitely some more value to be had in those pieces. But for today, I really wanted to focus on, if you believe in problem strings, then I don't recommend that you do those at vertical non-permanent surfaces with visibly randomly chosen groups, because they won't have the punch you can have if you do them at all. They'll fall flat, and then you'll get frustrated. The kids will get frustrated, and we won't develop the math. And then you have the potential to throw it all out. And I don't want you to throw it all out. Like Kim just said, I want you to use Peter Liljedahl's first chunk there when it's appropriate with good, rich curricular tasks. And I want you to do whole class, teacher in charge in the right way, facilitating the learning towards a goal, representing thinking, crafting careful conversations, purposeful conversations when you're doing things like problem strings and other instructional routines that are very helpful parts of a good balanced math curriculum. All right. That was kind of fun. Hopefully I did that justice. If anybody thinks that I kind of didn't do something justice, I'd love to hear more on your take. Keep in mind that we're going to talk about the rest of, at least some of the rest of his points that deserve some uplift for all of us. Highly recommend that we all build thinking classrooms. It's just maybe how we do it, in which parts that we're going to kind of fine tune a little bit. And then remember, I'm also about the what. That there are major strategies. It's not just some random collection of whatever kids do. It's also not the algorithm. There are specific things we need on the landscape of learning that we need to develop in kids, and we need to know what those are. We need to know our content and know our kids in order to really teach math that is FigureOutable. All right. Kim, do you have anything to add, or is that good?
So good. Yeah.
Cool. All right, y'all, thank you for tuning in and teaching more and more real math. To find out about the Math is FigureOutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is FigureOutable. Thank you for listening and making math more FigureOutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more FigureOutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.